So, number one, it's telling us that the two triangles here are congruent. So do you guys remember what that means, if we know that they're congruent? We know that corresponding sides will be congruent, as well as corresponding angles will be congruent. So if we're trying to find x, which angle does x in here match with over here? E. So if I can find angle E, then I can find angle x. So can anyone figure out a way to find angle E? So when we look at this triangle, I notice that I have a 90 degree and a 60. So if I were to do 180 minus 90 minus 60, I get 30. So that means angle E here is 30. So what does angle x have to equal? 30. Okay, number two is using the same idea. We're told that R and W are the same and that they're both 35. We're told that V and S are the same and they're both 72. And we're told that RT, this one here, is congruent to UW. So based on what's marked, can we say that these two triangles are congruent? Yeah. By which postulate? Two angles and the side not in the middle. So because we know they're congruent by angle, angle, side, what does UV have to equal?
5.
So UV is this side across from the two angles. So here's our two angles. It goes with ST, so it has to equal 5. Number 3. If we were going to try to prove these two triangles were congruent, what postulate would we use?
Side.
It's not side, angle, side. Angle, side, angle, because we have a reflexive property in the middle. So we have two angles and the side in between, so angle, side, angle. Okay, number 4. So it wants us to name all the corresponding parts in these based just on the congruent statement, and then to write another congruent statement that could work for the same triangle. So to start off with the sides, remember it's the first two with the first two. So RS would be congruent to FE. The last two, so ST would be congruent to EG. And then it's the first and the last. So RT would be congruent to FG. When it comes to the angles, it's just matching up R with F, because they're both first. Oops, forgot the angle symbol. R and F. S will go with E because they're both in the middle. And T will go with G because they're both last. So when it comes to a new congruent statement, start by just picking a different order. So did anyone pick a different order for RST? What'd you pick, Max?
STR.
All right, STR. So then how would that change our second triangle?
And that's congruent to EGF.
EGF. So that's what it meant by a different congruent statement, is something that works but just mixes the letters up, so you mix them up the same way, so they're still congruent. Okay, number 5, we're still dealing with just the congruent statement. Choose all corresponding congruent statements given that you know the two triangles are congruent. So, is M congruent to P? Yes, so we can circle it. Is ON congruent to QR? So ON to QR. Yes, because they're both the last two in each statement. MN is congruent to PO. So M and N are the last two. And that should be a PQ, I believe, not an O. So MN is the first and the last, PQ is the first two. So those do not quite match, so we won't circle it. And so, again, there's supposed to be a triangle symbol there. Triangle NOM, so that would be reading this backwards, NOM. Is that congruent to RQP?
Yeah.
Yes, so we can circle that as true. O and R, do O and R go together? No, because they're not in the same location in the statement. And then FONM, so starting in the middle, ONM, is that congruent to RPQ? No, because O is supposed to match up with Q, which it doesn't over here. So that one should have only had A, B, and D circled as true statements. Okay, last one on this front page. We're trying to find angle DCN. So DCN is this one right here. That's the angle we're trying to figure out. What additional information is needed to know that these two triangles are congruent? So if we were trying to say these were congruent, what do we know over here? We know 68, 75, and a side. Over here, what does this one arc tell us? It tells us that it's 68. Now we also have the side already. If we were to mark vertical angles, so the additional information we need to know is to be able to mark vertical angles. So angle DNC is congruent to angle SNR because of vertical angles. So then we would be able to say for sure that the measure of angle DCN is what? What would that missing angle be now that we know for sure they're congruent? 75, because now we know C and R have to go together, so it would have to equal 75 degrees. Okay, before we go on to the next page, are there any questions or clarifications needed on 1 through 6?
Wait, so do you have to write that number 6?
Because it said what additional information is needed to know, you at least have to identify this part, the vertical angles. It didn't ask us the why, but I wanted to just go over the why because it's something we do in our proofs. Any other clarifying questions at this point? Okay, next page. So here we have corresponding figures. So again, we can match up like parts from the statement to help us find x and y. So I notice that my x is located on side QR. Well, QR are the last two letters of this statement, so it has to match up with FG. So that means that I can write the equation 2x minus 4 has to equal 12. So if I solve that for x, I get that x is equal to 8. Now for y, I notice y is angle Q. Angle Q has to match with angle F because of they're in the same location of the figure. So if F is 68, then 6y plus x has to equal 68. Well, we just found out what x was, so we can substitute that in. And we'll end up with 6y equals 60, so y would have to equal 10. So that one again is all about matching up like parts so that you can solve for different variables. Okay, so number 8, which postulate or theorem can be used to determine angle or the measure of angle R given that we know O and L are congruent? So O and L are congruent. We already are also from the picture told that ON and RL are congruent. Is there any other information we can mark in our picture that we know? We have vertical angles. So around M, we have vertical angles. And if you want, you can mark the side with 15 with a dash mark. So what theorem or postulate tells us that the triangles are congruent? Angle, angle, side. And why now, after we've been able to prove that they're congruent, can we say R and N are congruent? Corresponding parts of congruent triangles are congruent. Okay, and then let's see, number 9, again, we're finding values of x based on a congruent statement, or the fact that we have congruent triangles. So R, I notice, is the one angle that doesn't have a 2 or a 1 marking on it. So that means it has to match with the angle over here that doesn't have the marking. So I can put 5x right here in for C. So then how can I look at just triangle ABC to figure out what x is? So what do you know about the angles of a triangle? They add up to 180. So if we add them all together, and set it equal to 180, we can solve for x. Let's see, so we get 125 plus 5x equals 180. Let's see, we'll subtract 125 to both sides, and we'll get 55. Divide both sides by 5, x would equal 11. Okay, so before we go on to the bottom part of this, are there any questions on 7, 8, or 9? Chase? Okay, so 10 through 15, this, yes sir.
So for number 9, I did 80 plus 45 equals 125.
Okay.
And then I did 180 minus 125 equals 55. And then for C, I put 55. And then I did 5x equals 55 and divided them both by 5.
Yeah, that's the same thing. You just did yours in pieces, because if you look, what was the first thing I did? I added those together to get 125. Then what did I do? I did 180 minus 125 to get 55. Then I set 55 equal to 5x. So you just did yours in separate pieces, whereas I did mine all from an equation. So it's the same thing, so that works. Okay, so number 10 through 15. Let's see, choose a postulate or theorem you would use to prove the triangles are congruent. So A is where we're going to write our postulate. B is where we'll write the congruent statement. So if we look at number 10, are there any markings we can add to our picture? Chase? Okay, we can add our vertical angles. So are the two triangles congruent? Yes, by side angle side. So if we write a congruent statement, I can say triangle QRS is congruent to triangle. Let's see, so I started up here and went down, so T to U and then to S. So triangle TUS. Okay, what about 11? Are those two triangles congruent? I see some people nodding. By which one, Dana? By hypotenuse leg. So because they are both right angles, they have a hypotenuse congruent and one leg. They're congruent by HL. So we can say triangle DEF is congruent to triangle. And again, we have to make sure we match up like parts. So D came first, so H has to come first. So I went D to E, so H to G, and then finally back to F. Okay, number 12. Are those two triangles congruent? Why? Side, side, side. So we can make a marking on that shared side to be able to say they're congruent by side, side, side. So if we have angle or triangle PNM, that would be congruent to triangle MQP. And again, it's just a matter of matching up like vertices. Okay, number 13. 13, we need to make some markings on here to see if they're congruent. What markings should we make or could we make that we can tell? Okay, we have the reflexive property in the middle, so now we have one angle and one side. Is there anything else we can mark? Robert?
The parallel lines.
Well, the parallel lines are already marked, but what can they help us interpret?
If they're congruent.
Parallel lines are not congruent, but they give us something that is congruent.
Alternate interior.
They give us alternate interior angles. So alternate interior angles are congruent. So if we look at what we have marked, we have two angles and then a side knot in the middle. So we can say that they're congruent by angle, angle, side. So we can say triangle ACD, and then we just have to mark it, or match it, sorry. So ACD would match with DBA. Okay, 14. Again, I notice we have reflexive property, so I can mark that. Are the two triangles congruent? Chase?
Yes.
By which postulate?
Future.
Okay, so again, we have two right triangles. The hypotenuse are congruent. The leg is congruent, so we have HL. So triangle JKM is congruent to triangle LKM. Okay, and last one for this page, number 15. What markings can we add to our picture that we know? We can add our vertical angles. So we can mark our vertical angles. So are these two triangles congruent? By which postulate? Angle, angle, side. So we would have triangle MNL is congruent to triangle QPL. So on just these bottom 6, are there any questions or clarifications needed as to how we got any of those? Yeah.
Number 13, I got side, side, side because I put that K and M is like a midpoint for J, M, and L. So would that work or?
No, because we don't know that M is a midpoint. It doesn't tell us anywhere, and we can't make that assumption. So no, this one would have to be hypotenuse leg, because we just can't make that assumption. Any other questions or clarifications on this, on these bottom 6? Okay. Next page. We got 3 more like that. So let's see, 16, 17, and 18. So are these two congruent in number 16? Why? Okay, we can mark the reflexive property, and so we have angle, side, angle. So triangle QRP would be congruent to triangle. So Q goes with S. R up here has 1 marking, so it has to go with P, the 1 marking, and then R at the end. Okay, so 17, are those congruent? By what postulate? Okay, if it was side angle side, the angle would have to be in between the 2 sides.
Side, side angle.
This would be side, side angle, but spell that backwards, what do you get? A bad word. So this is one of our not enough information. And you want to make sure that, because this is on the test, if you have not enough information, you have to write it on both lines. Otherwise, it looks like you haven't answered a question. Okay, so this one is not enough information, because remember, bad words and batteries don't make congruence postulates. All right, what about 18? Is that a congruent, are those congruent triangles? Why? This one's actually not hypotenuse leg. Okay, even though yes, we do have the right angle, the hypotenuse isn't marked as congruent. It's the 2 legs that are congruent. So which one is this? This one's just side angle side. So if we had triangle ABC, that would match with triangle EFD. Okay, so before we move into the proofs, are there any questions on 16, 17, or 18? Because you have, I think, about 9 to 12 of these on your test as well. Yeah.
Does it matter part E? Is there only one right answer?
No, so like on this last one, had you put like BCA, your second triangle just would have had to be DFDE. So as long as you've ordered them so that the vertices match the one they're supposed to match, you can write it in whatever order. So when I grade it, I'll be looking more that your letters in each triangle match up, not that it's the exact same order as mine. But I will tell you on the test, I give you the first 3 so that there is only one answer. So like I'll give you the first triangle and you're just filling in the second. So that way there isn't that multiple answers. But for this, yes, as long as your like letters are matched up, the order is converted. But as like I said, so go back and just make sure, like, did you match R and P together? Did you match R and this R and P? Like, so just as long as they're matching, you can switch up the order. All right, proofs. So number 19, and so on your test, you are going to have some that are like this where you fill it in. So you're just filling in the missing part. You're not having to create the whole thing. So like if we look at 19, what should be something we write in the first step here? AE is congruent to CE. Is there anything else we can write up in there? AB is congruent to CD. Now, did you guys notice how there's 2 lines for given? That means we can write the second part, that E is the midpoint, in the second line. So if you notice that there's 2 lines for your given, because we told you that by giving you the 2 reasons, then you can separate your given. If you're only provided 1 line for it, then you would put it all on 1 line. Okay, so I'm going to go and just make sure my picture is marked. So A, E, and C, E are both marked. A, B, and C, D are both marked. Okay, so using the definition of a midpoint, what can we say is congruent? BE is congruent to ED, so that would be our third step. BE is congruent to ED. So then why are the two triangles in this picture congruent?
Side, side, side.
Side, side, side. Okay, our second proof. So they've already filled in for us statement and reason number 1. And they've also already marked them on our picture. So then it tells us that we have the statement angle BAC, so BAC is this angle here, is congruent to angle ACD, this one here. Why do you think that is? They're alternate interior angles of parallel lines. So alternate interior angles of parallel lines. So then it tells me I have to use the reflexive property. So what can I say is congruent by the reflexive property?
AC.
AC. So we can say AC is congruent to itself, AC, by the reflexive property. So why are the two triangles congruent? Angle, angle, side. And so after the triangles are congruent, why can we now say that BC is congruent to DA? Because they are corresponding parts of congruent triangles are congruent. Any questions on the fill-in proofs? The ones that help kind of guide you to what you might need to write.
Can you write for the reflexive AC plus CA? Or would it have to be this?
Keep them in the same order. So if you're going to do CA, then make the other one CA also. It's not wrong to, but okay, any other questions on the fill-in ones? Because then we're going to go into one where we have to go all the way through by ourselves. Because you will have one like that as well, where you have to do both sides all on your own. So if we look at 21, what should be our first statement? The given. So our statement number 1, angle K is congruent to angle M, and KL is congruent to ML, for a reason being given. And again, I'm going to make sure my picture's marked to match what my given says. Okay, so now if we look at our picture, is there anything else from how the picture is, or the diagram is, that we can say? Okay, we have vertical angles. So we need to make sure we're using 3 letters. So angle JLK is congruent to angle PLM because they are vertical angles. So do we have enough marked on our picture to say the triangles are congruent? By what reason? Angle, side, angle. So triangle JKL is congruent to triangle PML by angle, side, angle. How many of you guys got that one on your own? Good. All right. Then we also did some work on overlapping triangles. So for 22 and 23, we're just identifying the common angle. So what would be the angle in common? And this is where it might help to kind of highlight or use a color to draw out your triangles. If we have triangle T to P to Q, so that one that I just outlined in yellow, and then our other triangle is R to V, R to P to V, what angle is in common? So what angle got colored twice? Angle P. So that would be, we need P in the middle of our angle. So remember, the vertex has to go in the middle, so only one that has P in the middle is letter D. For 23, this one is where it really is helpful to sketch the two triangles that it's talking about, because we have a lot of triangles in this picture. So RST, RS to T, so we're talking that one there, with UTS, so U to T to S. So which side does this have in common? ST, because that's the side that has both colors going along it, so your answer again would be D. Okay, so 24 and 25 are again still dealing with the overlapping part. So this is where, because we're actually needing to write a congruent statement as well as state the postulate, this is where it's beneficial or helpful to draw your two triangles separate. So if I have my ADC and my DCB, I know they have the common side, and they're telling us in the given that AD is also congruent to BC, and that angle ADC, so this one down here, is congruent to BCD, this one down here. So when we separate them and mark them based on the given, are they congruent triangles? Yes, there are congruent triangles by side, angle, side. And so this is going to be more what it looks like on your test, is I'm going to give you the first one and you're going to match it up with the second one. So if we're looking over at this triangle here, what does D match with in this triangle? So C has to go first. What does A match with? B. And then what does C match with? D. So you would have triangle CBD by side, angle, side. So same thing for 25. I'm going to sketch them separate from each other. So I have J, K, N, and then over here I'll have K, M, L, and K is our shared angle, so I can go ahead and mark that. And then from the given, it tells us JK is congruent to KL, and that KN is congruent to KM. So are the two triangles congruent? Yes, by side, angle, side. So M would match with letter N, K would match with itself, and L would match with J. Okay, 24 and 25 are almost identical looking to how they are on your test, where you're going to want to draw them separate and then give the statement as well as the reason. Okay. So are there any questions on the overlapping parts of, or the overlapping triangles? Okay, 26. Transformations. Alright, so graph a triangle whose vertices have the following coordinates. So A is at 3, negative 1. B is at 5, negative 1. So we have A, B, and C is at 4, negative 3. So there's our starting triangle. Triangle ABC. Reflect it over the y-axis. So which one is the y-axis? Good, vertical, because on the quiz some people were reflecting it over the wrong axis. So vertical is y, horizontal is x. So if we're going to flip it over this line, you would, does anyone remember the rule for it? Negative x comma y. So if A was at 3, negative 1, what does A prime fall on? Negative 3, negative 1. So I can go negative 3, negative 1, there's A prime. B, which is at 5, negative 1, would give us B prime, so we just make the x negative, negative 5, negative 1. And then C, who's at 4, negative 3, just make the x value negative, and we get C prime is negative 4, negative 3. And that would be your reflection over the y-axis. So we also did translations. So for 27, negative 2, 1. Negative 4, 3. And then negative 4. Oh, negative 4, negative 1, my bad. Negative 1. Okay, so here we have our triangle for 27. But this time we're doing a 90 degrees clockwise rotation, and then we're translating. So on all of our rules, we were all doing counterclockwise, which means we were going this way. So clockwise, if I were to start here and go 90 degrees clockwise, that would land me over here. Well, which counterclockwise rotation would also land you here? 270. So if I were to go 270, that's the same as 90. 90 clockwise. So the rule for 270 was to switch x and y, but make the x negative. So this would be our 90 degree clockwise rotation rule. So if we start with that, A, which is currently at negative 2, 1, we would switch the x and the y, but make the x the opposite sign. B, same thing, switch the x and the y, and then make x the opposite sign. For C, we're going to switch x and y, and make x the opposite sign. So those 3 points right here are the 90 degree clockwise rotation. Then it wants us to translate it. X plus 2, whoops, comma, y minus 1. So now from these points, for x I'm going to add 2, y I'm going to subtract 1. So 1 plus 2 is 3. 2 minus 1 is 1. So my final point for A will be at 3, 1. For B, 3 plus 2 is 5. And for the y, 4 minus 1 is 3. And then lastly, C, negative 1 plus 2 is 1. 4 minus 1 is 3. So if we plot those final pink points, we have 3, 1, 5, 3, and 1, 3. So that final pink one would be our answer. Okay, any questions on the transformations? Yeah.
For these, do we have to write the prime points?
At least do something. You have to write at least a prime, just so that way you have. Oh, you mean these ones here?
Yeah.
No, you don't have to. As long as I can see your mapping here, you don't have to draw them on the graph. Some people like to, but you don't have to. I just need to see the start and the end, and then see how you got there. All right. Is this the one? No, we got more. Okay. 28, 29. So these ones, you're trying to find the mapping. So what did you have to do? And these are the ones that I'm going to give you patty paper for on the test. Are these ones where you have to come up with the rule? Did anyone come up with how to get from ABC to DEF? What did you have to do?
Reflect over x and go left 5.
Okay, so reflect over the x. So if we reflected over the x, and then translate it left 5. Wait, left or no, that's right.
Oh,
Yeah.
right, sorry.
Right 5. Then we should be good. Because 1, 2, 3, 4, 5. Okay, so that one works. What about 29? Anyone come up with how you might have gotten to 29? ABC to DEF. Chase?
Rotate 80 degrees clockwise and reflect over the x-axis.
Okay, so rotate 90 degrees clockwise, which would take us here. And then reflect that over the x-axis. So rotate 90 degree clockwise, reflect over the x-axis. All right. What about 30? Anyone get something for 30? Chase, did you get something for this one?
Let's rotate 90 degrees clock. Wait, are we going ABC to?
ABC to, so start up here with ABC and down here.
I kind of did FGH to
Okay, so what did you do?
rotate 90 degrees clockwise, and then 1 unit to the left and 4 units up.
I'm not sure that one will work. Danuna, what'd you get?
Reflection across the x-axis and then translation of 3 units to the right and 1 unit up.
Okay, so Chase, if we were to do yours but backwards, so you did the bottom one 90 degrees clockwise, right? Or counterclockwise?
Clockwise, yes.
So if you had started, yeah, anyway. So that means if we were to do this one counterclockwise, 90 degrees, it's not even in, we can't just translate it because it's not quite in the same position. That's why yours, it wasn't quite right. So Danuna, what did you say yours was?
Reflection across the x-axis.
So reflect across the x,
And then translation of 3 units right and 1 unit up.
and then a translation of 3 to the right, 1 up. Okay, so reflect across the x-axis and translate x plus 3 and y plus 1. Yeah. If you also want to leave it how you said as well, the 3 to the right, 1 up, that would work as well. Okay, what about 31? Anyone get one for 31? This time we're starting at DEF and going to PQR. So DEF. Anyone have a suggestion if you didn't get this one yet as to what we might want to try?
Rotate 90 degrees counterclock and right 1 down 3.
So counterclockwise 90 degrees, and then what was it? Sorry.
Right 1 down 3.
Right 1 down 3. Okay. So 90 degree counterclockwise rotation. Right 1 down 3. That works. Okay, so you're going to have a couple that you're going to have to, on the test like this, where you're going to use patty paper to determine your mapping. All right, so the only ones we haven't gone through, because class here is over in a couple minutes, are the isosceles triangle ones. So tomorrow we'll go through the last of the isosceles triangle stuff, which is what's on the back side and the last few here. So if you did not finish this yet, so let's say over the weekend it slipped your mind, you need to finish it by tomorrow, okay? We are collecting this, so make sure that it's done by tomorrow.